Hello, everyone. Want to thank you for tuning in. My name is Randy Reed. I'm a regional manager, sales manager for Hovair Automotive. We're a material handling manufacturer based in the greater Indianapolis area. We have been supplying innovative solutions with a high degree of responsiveness to empower our customers to be more productive for over 35 years. Before we get to the demo, I wanted to briefly let you know about Hovair's relationship with Rhino Toolhouse. Many of you are familiar or have worked with Hovair in the past, and some of you are tuning in because you have heard about us via Rhino Toolhouse representatives or our Hovair representatives. In November in 2019, Hovair was purchased by Rhino Toolhouse. The partnership has been a great fit for both parties, as we at Hovair have been able to gain a larger sales force using over 50 sales and applications engineers located over 36 states. And the Rhino Toolhouse side has gained a direct centrally located manufacturing company that is able to serve all of Rhino Toolhouse's customers. Hovair and Rhino Toolhouse are functioning as one company and serving all customers. Hovair manufactures rack handling equipment, lift and tilt tables, turntables, automated conveyor systems, custom material handling, and machinery. Today I'm here to review with you our inline shuttle system. The reason someone would want a shuttle system is currently if you have multiple forklifts supporting an operation of production, you have multiple part types being stamped down the same line, multiple part locations on one line side, walking distance to load and unload parts are great. And often the line shuts down while they're waiting for the racks to be exchanged by the fork truck. The resolution for this is if you use an inline shuttle, it reduces the fork truck traffic, because basically the fork truck can bring over 2 racks at a time and load the system and take away 2 empty racks. It keeps the line running without any downtime, and the operators are more effective because they have less of a walking distance. Here is a layout of a plan view of a plant showing 2 tailgate lines. You can see the aisle down at the bottom for the traffic. They have AGVs and fork service to the shuttles. There are 2 of them here. They have 3 stations for 3 racks. They will shift to the right, then back to the left as the parts come down this conveyor here, and they load them into the racks. They will slide them in, hit a button, the conveyor indexes a few inches, slide in another tailgate, hit a button, it conveys over a few inches, and it just increments across so they can keep loading and sliding the parts right into the container. They use the shuttle line side like this because of so close to the aisle, they don't have space for a traditional air-bearing turntables or other rack handling systems. Here's a nice picture of a 3-position shuttle. We call this a 3-5 shuttle, if you will. There's 3 racks and basically 5 stations for racks. So as it conveys over, they're able to unload the first 2 while the operator is working out of this station. The fork truck driver is able to exchange those out. Then he moves over, the fork truck can change this one out, etc. Here's a typical drawing, if you will, 3D model of a system showing 3 placeholders for racks. Going right straight down the center, you have a pathway that the drive packages runs on and a cable carrier off to the side. So the shuttle is all pneumatic. It runs with on a pneumatic drive package. There's a side view. In this view, you're showing really how low to the ground profile it is. This thing is like maybe a foot off the ground. And you have base rails that are lagged to the floor and a shuttle on top that goes left to right. You got your yellow toe guards so the operator's feet don't get underneath the shuttle. An end view is showing on the system. You have two sets of rails. These are hardened rails that are in the base frame, and they run on basically D-mag crane wheels. These are the wheels used in cranes. They interface with the hardened rails. The systems themselves like that, they do not run out. You have a drive package. You see the two drive wheels down below. It's all hidden behind the container here, but what you're looking at up front is, up top is, you have a gearbox, an air motor, a pivot bracket, and two wheels. Those wheels come in contact with the base frame through the airbag that presses down on the package into the frame, and you're getting your motion that way. So then here's a plan view showing you better. These are the pathways that the drive rides on, and you have a cable carrier going back and forth because the drive package is sitting under the unit on this end. In a typical system, you have fork trucks loading material on this end. You can see as it increments across, they're filling the parts. It gets to the other end, then they unload those three, and it just reciprocates and it goes back in the other direction. Now here are some photos of the shuttles showing you again the pathway. This system has turntables, rotate tables on top of the shuttle, because some of these containers, they need to be able to get at both sides of the rack for the parts, so they're able to rotate the parts around or the rack around. Here's the same system showing that you got 4 rotate tables on top of the system, your toe guard on the side, your drive package is under this end right here. And here's the installation in the plant. This is for an automotive manufacturer, and they have hoods that they're sliding in the racks. So this system is again holding 3. It's just shuttles back and forth, back and forth. The systems only run on air. They don't require any electric at all. And then here's the door line. You got doors that they're sliding in. So you basically have doors, hoods, tailgates, any parts that you can slot, or a narrow aisleway where you can put this parallel with the line. They're showing you basically the layout of a system for the 108 tonnage. You have 780 inches overall because you have enough for basically the system at this end and the system to the right, so you can get the parts all the way from one end of the rack all the way to the other end of the rack. The ease of installation of the systems, you have a base frame that's coming in 3 pieces and a top frame that is split in the middle. So that would roll off on each end and travel with that system to be set in place. At the plant, they would set all base frames, lag them together, level lag, bolt the 2 top parts together, connect the air, then you're good to go. Here's a better picture showing you of the drive package with the airbag on top, driving the wheels into the base frame of the system, double shafted gearbox, air motor, and the drive wheels themselves, and the pivot point of the drive package. Once again, these are just to recap on the system, the reasons for basically the need for an inline shuttle. and the resolution of why it would help. I'd like to thank you for joining me today. If you have any questions, our contact information is located at the bottom of this, the last pager. Thank you.